Hello, everyone. Welcome to Linux Forensics here at Pen Tester Academy. I'm Dr. Phil Polstra, and I will be your guide throughout this course. Now, some of you might know me, and if you don't, just a little bit about me. You might know me because I'm a very frequent conference speaker. I've done some repeat performances at DEF CON, Black Hat, GurCon, 44Con, B-Sides, Forensic Cure, and a few others. I'm also an author. I wrote a book called Hacking and Penetration Testing with Low Power Devices. It was published in September of 2014, and it's all about how you can make your own remote hacking drones, drop boxes, etc., using the inexpensive yet powerful BeagleBone Black, and how you can take a bunch of devices, put them together, possibly battery power them, and hack people from a mile away. So that's what that book's all about. Also have a couple more books planned for 2015. And my day job, I'm a professor teaching digital forensics at Bloomsburg University of Pennsylvania. I've also been programming for a while. I started when I was 8, and when I was around 10, I learned assembly, and I've been hacking hardware since I was around 12. Also been known to fly, build airplanes, teach people how to fly, and things like that with my free time. So about this class, what's coming up with this course? Well, we have a lot of exciting things coming up in this course. Now, this is not necessarily a comprehensive list, but just to give you an idea, we're going to start out with live response. So live response, you've walked into a situation where someone thought that you might have something going on that needs investigating. So the first thing we'll talk about is how do you interact with humans? It might sound a little strange given that this is a technical course, but it's in your best interest to talk to the people involved first before you decide what to do. We'll talk about developing your own live response kit, how you can send your data across the network in order not to disturb the subject machine too much. We'll talk about collecting all that volatile data and figuring out, is it worth it for me to do a dead analysis or not? Should I really take this machine offline? We'll show you how to dump RAM for later analysis. We will talk about acquiring file system images using standard tools such as DD and the enhanced version DCFLDD. We will also necessarily talk about write blocking, and we will cover both software write blockers, such as those that you could create with UDEV rules or if you use a forensic Linux distro. And we'll also talk about hardware write blockers. We will dig down into file systems, and we will show you how you can mount them onto your Linux system, how you can find the strange, things that are not just quite right that probably indicate somebody did something and tried to cover it up. We'll talk about different searching tools and looking at things such as authentication related files, how you can recover deleted files, and how you can find hidden information. We will also leverage open source tools such as the Sleuth Kit and Autopsy, and we'll show you how you can use these to investigate at the volume level, the file system level, and then drilling down a little bit, how you can look at inodes, directory entries, etc. One of the things that we're going to spend a lot of time on is constructing timelines. How can you build a timeline of what happened when in order to figure out what occurred? So we will spend some time on timeline analysis, so you can look at things such as when was the system installed, upgraded, booted, etc. Did somebody reboot the system because they did something bad and they needed to install it. We will look at newly created files that could be malware, recently changed files that could be Trojaned, and files that are in the wrong place, such as files in the dev directory, for example, that might be used for some sort of exfiltration. We will dig even deeper into some of these Linux file systems. So we'll use a couple of editors to do this. We will use the free Active@, disk editor. We'll also use the free and open source Autopsy product. We will look at the Ext family of file systems in detail, and we will also look at some of these emerging Linux file systems. We will show you how to search unallocated space that's not part of a file system as well. Then we're going to turn our focus to network forensics. We'll show you how you can use Snort on your packet captures in order to detect the strange. We'll show you how you can use tools like TCP-STAT, and we'll also show you how you can separate conversations. You can have this deluge of network packets going through the system, and you can separate them out using TCP flow. We will also talk about looking at backdoors and detecting them. We're going to drill down into the file level, and we'll talk about how you can figure out what's in a file. Things like file signatures, how can you find files hidden in swap space? We'll look at web browsing reconstruction. Can you find somebody's cookies, search history, caches, etc.? We'll investigate unknown files. If you don't know what it is, you can do things like compare the hashes to known values. Perhaps it's malware that's known. We will talk about other things such as using the file and string commands, how you can look at the symbols inside of a file. We'll talk about reading ELF files and using tools such as objdump and in some cases GDB if it's an executable. We will spend some time on memory forensics. So we will look at things like building volatility profiles, retrieving process info, command line arguments, rebuilding someone's environment variables, listing open files, retrieving their bash history, getting all those network artifacts, kernel information, all that volatile file system information, and of course detecting rootkits of various types. As if that wasn't enough, there's more. We're also going to look at reversing Linux malware, digging deeper into that ELF format, looking at headers and sections, strings, symbol tables, program headers, program loading, dynamic linking, and looking at some more command line tools such as strings, strace, ltrace, etc. And we'll also talk a little bit about carefully running malware and how you can do that. If you have something you're really having a hard time figuring it out, then we'll tell you how you can use virtualization and other things in order to look at that malware. We will also talk about everybody's least favorite part, writing reports. So we'll talk about a couple of tools out there that can ease that pain a little bit, such as Autopsy, Dratus, and even OpenOffice. So what can you do to lessen that pain? Overall goals for the course. I want to leverage open source or at least free software to the maximum extent possible. In other words, I want you guys to go through this course, and at the end of it, I want you to be able to go out and actually do stuff without dropping a ton of cash. So that is a huge goal for this class. As with every class here at Pentester Academy, this course will be very hands-on and it will involve a lot of practical exercises and demonstrations. Another big goal, we want to provide the most comprehensive Linux forensics course available. I think if you look at the contents for this course, you get an idea that this is a substantial course. And I'm really looking forward to delivering this course, and I hope that you will all enjoy going through this course together with me. I will see you soon in our first video.
Hello, everybody, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to talk a little bit about forensics basics. So we'll start with, what is forensics anyway? So forensic is a noun that means belonging to, used in, or suitable to courts, etc. So a lot of times people look at forensics and they say forensics is something that has to be in a court situation. But I like to look at the part of the definition that says suitable to courts. In other words, our goal is to gather evidence that's of sufficient quality that it could be used in court, even if it is not intended to be used in court. And we'll talk about that along the way. One thing that is very important is you should never be careless as you gather evidence because you assume it's not going to show up in court, because you never really know. You might start investigating an incident, and the next thing you know, it's a real incident and there's been a breach, and people are going to try to figure out who did it. So forensic science, or just forensics, is the scientific collection of quality evidence. Now, the world of forensics is pretty large. There are a lot of different kinds of forensics that you can do. I like to break it into physical forensics, the typical stuff that you see on shows like CSI, where, they talk about things like transfer. That's one general principle in forensics, that whenever two bodies interact, there's some sort of transfer between them. So things like paint that gets rubbed off when you run over somebody in the highway. Fingerprints are another common piece of physical evidence that's collected, and everyone's favorite, DNA. We also have digital evidence, network forensics. We'll talk about that in this course. We'll look at data storage, investigating things that are stored on various media. Well, we can also look at small devices, things like your phones and tablets, etc., which store information. Incidentally, some of those small devices are running Linux, so some of the things that we talk about in this class might be relevant. And then we have computers. So what are some general principles when it comes to doing forensics? One of the biggest things you have to be careful about is to maintain the integrity of the evidence. Don't destroy the evidence. I read a book recently, and I won't name the book, but in the book there was a program for gathering some information from files, such as when they were last accessed, and the program actually opened the files before gathering that information, destroying all the evidence. The other thing is that once you've collected evidence, you have to maintain what we call the chain of custody. So you have to make sure that that evidence doesn't become corrupted. If it's physical evidence, typically it goes in a bag with a label, and on the label is every person that took it out of the bag. Another principle: document everything. Now, I know that we're technical people here and we like to use technology to document everything. Sometimes handwritten is better. If you want to handwrite something in a bound notebook with numbered pages, that's the best. No one can come back later and claim that you suddenly inserted a page or removed a page from your notes. Also, if it's possible, try to work with a partner. That way, one person can document while the other person gathers evidence. Also, it's harder to challenge what two people say. If one person is alone, you might get accusations like, he planted that glove in the alleyway, for example. And always follow standard practices. If you follow standard practices, that doesn't require a lot of explanation in court if you end up there. If you did your own thing, then that might get questioned. So there are different phases of an investigation. And the first phase is to preserve the evidence. In the medical field, they have this concept, first do no harm. So it's very similar. Don't walk all over the evidence. Then search for evidence. Now, this has become more lengthy and time consuming because storage media has exploded in size. We have 3 terabyte drives on desktop computers, and they have lots of RAM. And we have thumb drives with huge capacities, etc. And then once we've gathered the evidence, and evidence is just information, we have data, which is just bits and bytes, and then we have information, which is that data with meaning, and then we have evidence. Evidence is information that supports or refutes some sort of hypothesis. For example, I might think that Bob has embezzled funds from his company. So I'm looking for things that would either refute or support that. And I reconstruct the events. We'll talk a lot about that in this course. So incident response, first thing you want to do is validate that there was an incident, and then you proceed with preservation, searching, and event reconstruction. Now, you might need to do some preliminary investigation to determine if there was an incident. And it's never done till all the paperwork is done. So until you've done all the reports, your work is not over. So here's a high-level view of the process. So someone calls you. So we got a call, and they say, I think there was an incident. So you come, you do some preliminary investigation, and wasn't an incident. Well, you can take away from that some lessons learned. You can say, why did they think it was an incident? And you can file that away for future use. Or it was an incident. Now you can do some live analysis where you're working on the system that's still up in order to gather information. After you've gathered a little bit of information and probably processed that to some extent, you're going to ask yourself, is this a case where I need to perform debt analysis? And if the answer is no, well, then you write your reports and talk about lessons learned. If the answer is yes, you acquire images, and then you perform your debt analysis, and of course, write the reports and talk about lessons learned. Well, that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, make sure you tell a friend. I'll see you soon. Hello, everyone. Welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to talk a little bit about some first steps. What do you want to do first when you're getting into a forensics investigation? Now, recall from last time, we talked about the high-level process, and we said a call gets placed, and then you have to decide, is there an incident or not? If not, lessons learned are recorded. If so, you're going to start some sort of analysis, starting with live analysis, and then possibly dead analysis, and of course, everyone's favorite stuff comes later, writing those reports and documenting lessons learned. So, you have to be prepared. So what does it mean to be prepared? Well, you should have a response kit. And realistically, you should have more than one. You could store everything you needed for both 32-bit and 64-bit systems on one media, but you could also have something separate. All right, so you need to have a complete set of system binaries. Well, why do you need that? If someone has compromised your computer, you cannot trust any of the utilities on that system. Someone might have Trojaned the PS tool, the LS tool, all of them. So what you need to do is you need to mount an external media, and that can either be a CD-ROM or a USB. Now, some people would recommend the CD-ROM over the USB, with the thought being that there is very little chance that a compromise of your Linux system involved the CD-ROM. So there's no contamination, if you will, of references to the CD-ROM from your mounting things and from an attacker mounting a CD-ROM. USB is slightly more likely, but honestly, it's probably fine if you just want to use USB. Also, not every computer has a CD drive anymore. Hardware. What kind of hardware do you need? You should probably have a write blocker. We'll talk more about those later if you're going to perform some sort of dead analysis. And some media. Something to back up the target computer onto. This could be a portable hard drive or something else. And naturally, you'll need your forensics laptop. I say laptop, it could be a desktop, but that's a little bit hard to lug around with you. So ideally, you're going to have a forensics laptop computer. You should also have things like your bound notebook with the numbered pages for documentation, etc. So what about your workstation? What should it look like? I would recommend that you have at least 8 gigabytes of RAM. If you have less than 8 gigabytes of RAM, then you might have some performance issues. Also, I would recommend that you have at least one USB 3 port. If you're trying to make images of hard drives, which you've connected through USB to your laptop, it's going to be a little bit slow if you are restricted to USB 2 speeds. Also, I recommend that you have wired networking available. Maybe you like your thin little MacBook. However, in some cases, it's better to have a wired network. In particular, if I'm going to connect to a machine that's been compromised and try to use something like Netcat to get information off of it, I would prefer to use wired networking, and in some cases, I might even use a crossover cable to connect to that machine. Naturally, like all real work, it requires Linux. I recommend that you use a 64-bit Linux. There's really not much reason to still be using 32-bit Linux. You could use a specialized distro such as Sift from Sans, or you could use Ubuntu, or you could use your favorite distro. I will say this, however, Ubuntu is the most well-supported distro when it comes to InfoSec in general. And there's a reason why, my Linux distro for the BeagleBones is based on Ubuntu. Sift is based on Ubuntu. So there are reasons for these things. So, I know a lot of people aren't big fans of Ubuntu. I'm not necessarily a large fan either, but I use it because it is well supported. So how do you get the appropriate tools on your laptop? Well, you could install Sift, and if you want to install Sift on top of Ubuntu 14.04, you can execute this command, this wget command, and it will go out to GitHub, and it will pull down a script, and then it's piped to a bash shell, and this will install Sift on top of Ubuntu 14.04. Incidentally, if you check and you look at their website, you will see that you could install Sift in a virtual box. I don't recommend that for this situation. If you have a situation where you're going out in the field and you're trying to do some incident response, I think it's kind of silly to run up a virtual box inside of your machine. That's just me. Now, if you're like me and you like to use your everyday Linux instead of some specialized Linux, you can just install the tools on top of Ubuntu 14.04 by using this script. It's the same wget command, it just has less options here. It just says -I. Hey, give me the tools, but I don't want all the other stuff. So let's show you how this works. So here on my Ubuntu laptop, I've installed, or I'm going to attempt to install rather, Sift. So here's the script, wget, and see what happens when I do this. It tells me Sift is only installable on Ubuntu 12.04 or 14.04, which is kind of a downer, but don't worry about it. Okay, so it's telling me you cannot install this on your computer because I happen to be running Ubuntu 14.10. And perhaps by the time you're watching this video, you're running a later version of Ubuntu that's also not supported by Sift. Well, what I did is I wrote a pretty simple little shell script that will allow me to install all these tools. Again, it's nothing really special about Sift. It is just going to add 2 repositories and then install a bunch of stuff. So here I have my script, which starts with the pound bang or hash bang or shebang, depending on who you ask. And then I have, after that, my list of packages. And before my list of packages, I create some repositories. Now, I'm doing these kind of the backwards way. So just so you know, why am I doing it like this? Because I am not running Trusty, but Trusty is the only supported version of Ubuntu for these repositories. I lie to it and I tell it, please connect to Trusty. And This is the easiest way to connect to an older repository on Ubuntu. So I'm running 14.10 instead of 14.04. So I installed the 14.04 repositories, no problem. I directly install a couple of files in my app sources list.d directory. And then I have my list of packages. So here's my list of packages. It's fairly long. Before I do my install, I call apt-get update, since I just added 2 repositories. Here is a simple shell script. I say for package in package list, that huge list that I just scrolled through, do this. The first thing I say is it already installed? That's what this does. I run dpackage list, pipe that to awk. I print out the second item and grep for the package name, and I send the results to dev null, or the errors at least. So if that succeeded, then I just echo out, yeah, I already have it. Otherwise, I'm going to try to install it. So I'll echo out trying to install, name of the package. I'll call apt-get install. Again, the errors go to dev null. And if that succeeds, then I will say it succeeded. Otherwise, I will say that it failed. And that's pretty much it. It's a very simple script. So if I again go out to my terminal window, I already have my failed attempt, and I run this script. Now in my case, I've already run this. So it's going to scroll by pretty quickly and tell me, yep, I've already done all of that. Now, in the case where you haven't already installed all of these things, you could look at a couple of hours to install all of this. It really depends on the speed of your system and if you have a good internet connection, etc. How much you already had installed. You know, if you're working in InfoSec, there's a good chance that a lot of this was already installed on your system anyway. Well, that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, make sure you tell a friend. We'll see you soon.
Hello, everyone. Welcome to Linux Forensics here at Pentester Academy. In this video, I want to continue from the last video. In the last video, we showed you how you could make your Linux Forensics drive and install something like Ubuntu on it, and also copy over your system binaries onto a second partition that was formatted with ext3 or ext4. So here I want to show you how you can boot that thumb drive into VirtualBox. And this will allow you to update that system without having to tie up one of your computers for hours while you're trying to install SIFT. So here's the command. You're using an internal command inside of VirtualBox, and you're using the tool VirtualBox Manager, VBox Manage, and you tell it, I would like to run an internal command. Notice it's internal commands, and the command is called create raw vmdk. You give it a file name for your output, and here I'm just putting it in my VirtualBox main directory, and I give it a raw disk. So this will take dev SDB, and it will create a VMDK file, a virtual hard disk file, for the device dev SDB. Now, a couple of things to note. This assumes that your device is dev SDB. As you know, sometimes if you plug and unplug, it might become dev SDC, etc. So something to note. The other thing to notice is it's SDB, not SDB1. It's not the partition because you need that bootloader in order for this to work. So I enter the command, and I'm running this as root because if I don't run it as root, it's going to give me permission problems. And it's going to be very unhappy with me if I try to run this. So this is one of those cases where it's just easiest to run it as root. You could try to run this command as root and then change the owner of the file that's output from it. I found that that is a little tricky because then when you try to run VirtualBox, that user does not have access to the raw device. So once you've done that, go ahead and run up VirtualBox. Create a new system, and I'm going to call this one Linux Live. I'm going to click Next. I'm going to give it a decent amount of RAM. If I don't, it will be very, very slow. I'm going to use an existing hard drive, and I'm going to browse on over to wherever I put that USB VMDK file. And I'm going to click on Open, and I'm going to click on Create. Now you're almost done. One little tweak that you might have to do. If you click on Settings and you go to System, and you might need to check on Enable EFI. It says Special OSs only, so apparently Linux is a special OS according to the folks at Oracle. So once you do that, I should be able to go ahead and start. And this is coming up on another screen, and I'm going to try Ubuntu without installing. And it's giving me some warnings, but sure enough, I'm getting Ubuntu installed. Or rather, I'm not installing Ubuntu. I have a live version that's being installed. And why is this important? Well, again, this is actually writing to my physical thumb drive. So if I look at my thumb drive, I can see that the lights are flashing on it right now. And of course, as with all live Linux systems, it is a bit slow, and it will eventually boot to my desktop. And here it is. Once I'm here, if I want to install all of those SIFT additions, those additional repositories we talked about before, and perhaps some other things, I can access the internet using my browser, Firefox, or whatever you would like to install. And then I can have a live Linux thumb drive that is running something with a bunch of forensic stuff on it.
That's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you next time.